Past few years, I've finally come to the rationalization that by spacing everything out over the course of 3 days, by writing out all the different definitions and things, a lot of it gets lost. A lot of it gets lost in translation as far as what do the diagrams look like, how do things work, and how can you make diagrams work. So I'm doing it differently, completely differently this year, and I think that it's been working well because the first two classes that I did this way kind of flew through it. So what I'm calling this alphabet soup is that there are going to be about today we're going to talk about 5 different ways that we're going to be able to show that triangles are congruent. Not doing it via proof or anything, but just showing within diagrams what you can mark up and what you can't mark up, just from given information. So the first one we're going to use is called side, side, side. This is where the alphabet soup comes in. I'm not writing things out. I'm just going to use these abbreviations of the letters. And as you start to see how these things work, where the letters are placed and the order in which they're placed make a difference. Okay? So basically this says is that if you have 3 sides of one triangle that are congruent to 3 sides of a corresponding triangle, or the sides correspond to one another, those 2 triangles are congruent to each other. Okay? Just by using that diagram. I'm not going to read or write out the entire long-winded definition of if 3 sides of one triangle are congruent to the corresponding 3 sides of another, then the 2 triangles are congruent. That's a waste of time. Draw a picture, put tick marks on it, and you have 3 sets of sides. You have 3 sets of sides. Triangles are congruent because of side, side, side. He stole all the markers. There were 6 markers up here today. Thank you, sir. That would have been my luck.
You sure you didn't misplace it?
No. Oh, did you do that again?
No, I didn't steal anything last time.
I didn't do that.
Last time.
Or any other time.
So you get what's called side, side, side. The 2 triangles have those 3 things mixed, set up like that. It works. As long as they're in some sort of correspondence, we'll worry about how we label them later. That's an easier thing to talk about later on. I just want to get the basics down today. All right. The next one. Side angle side.
Oh.
Where is this angle placed within the 2 sides?
In the middle of the
In between them. When the angle is placed between them, it's called an included angle. It's included within the sides. It's a very, very easy thing to show in a diagram. A side, an angle, and then a side. I don't, pace yourself, pace yourself. Which means the other diagram would also look like a side, an angle, and a side. Now, would it make any difference if this secondary triangle was flipped like that?
No.
Because it's still 1 tick mark, an angle, and a double tick mark. It still matches up within the correspondence. It doesn't matter. Yes, ma'am?
Why do you put like 1 tick mark and 2 tick marks?
What that's showing is that just when you have single tick marks, that means that, for example, this could be a 4, and this could be a 4, this could be an 8, and then 8, and this could be a 7 and a 7. All 3 of them are different measurements. So 4 is congruent to 4, 8's to 8, 7's to 7. If this happened to be, for example, if this one was 2 tick mark, this would have to be 8. So then that just means that they match up. Their values match up. Does that make sense?
Yeah.
That's all it is. This still means that they're still congruent by side, 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 because you have that correspondence.
Okay. So it's just
Yep, that's all it is. It's just the way that they match up. There we go. Side angle side. The angle is between the 2 sets of sides that are congruent. Well, wait, there's more. There is angle, side angle. Now that basically means that you've got two angles and the side between them. Two angles and the side between them. Okay. Notice how my diagram, I've got a single tick mark side between one tick mark angle and a double tick mark angle. That means my other diagram doesn't mean however it's placed has to look the same. Single, same basic idea. Those two would be congruent to each other because the corresponding matches up. Okay? Not too bad so far? An offshoot of angle side angle is angle angle side. Which means you've got two angles in a row and then a side. Notice the side that I picked, that is, which angle is it across from? It's across from the one with the single arc, which means the other one has to also be across from the single arc. The correspondence stays the same. Okay? The correspondence stays the same. That single tick mark is across from the exact same angle. If it was across from a different angle, it won't work. Okay? It won't work. What's next? Angle side side. There is no ass in math. No, seriously. No, side side angle is just a backward ass. Go ahead and say it. It's okay. Everybody go ahead and say it. It's funny. It's a fun day. You can swear. There is no ass in math. Go on. Yes, please say it. It's okay. There is no ass in math. Come on, everybody, let's go. Come on. I'm serious. There is no, come on, you can do this. It's okay. There's what? There's no ass in math. Come on. Seriously. There's no ass in math. It's okay, you can say that. There's what? I won't tell her. Close your ears. Everybody close your ears. Go ahead, no, I don't want to. It's okay. Write it down and show me. See? And then we'll throw out the paper. Nobody will ever know what happened. Here, write it on the whiteboard. And nobody will ever know. Because we'll erase it. You can say it. Yes! Timed at 8 minutes and 48 seconds. Be here. No, seriously. There is no such thing as angle side. It's not. Angle side side is what we call an ambiguous case. It's a case that can occur, but it's not something that is definite. Angle side side does not always occur. There are, I think it will be on Monday when we come back from the 3-day weekend, because we haven't enough time off in November yet. When we come back on Monday, for our full week of school of November, what we're going to do is there's a program that we use on the computers, obviously, that's use what are called virtual manipulatives. And what we're going to do is we're going to move around triangles and we're going to move around segments and angle measurements and try to create congruent triangles. And the way that we're going to do that is we're going to try and create things with side, 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 angle, 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 side. And then you will see that sometimes there is a special case that side, side angle does occur, but it does not always occur. So that's why we say it doesn't exist, okay? But what does exist is this one. This one is called hypotenuse leg.
Oh, I hate.
Now, this one isn't so bad because what kind of triangles have hypotenuse? Right triangles, very good. Hypotenuse leg only can happen, and I want to put could in parentheses, be a good idea.
That's not parentheses.
Quotations, whatever. Hypotenuse leg is only one that can happen inside. It's one of the options that could happen with a right triangle. Hypotenuse leg will never happen with any other types of triangle because no other triangle have a hypotenuse. In a right triangle, do you guys remember which one is the hypotenuse?
It's the, yeah,
It's the long side, it's across from
the right.
the angle, yeah. The hypotenuse is the one that's always across, or opposite. We use the word opposite a lot in geometry. The one that is opposite the right angle. Okay? So, in a right triangle, you always have a hypotenuse. In case you're wondering how to spell hypotenuse, people, this is hypotenuse. Hypotenuse. In case you were wondering. So right off the bat, in a right triangle, if the two right triangles have this, they always have the same angle because we all know that 90-degree angles all measure the same. 90 degrees will always be congruent to 90 degrees. But if we wind up with a hypotenuse that's the same, then all you have to be able to show is that one of the other legs is the same. And this can happen because now, this is that ambiguous case that allows you to have side-side angle. It does occur, but it only occurs in one special case. It does not occur anywhere else. So that's why we say there's no ass in math. There's hypotenuse leg. What? It's kind of fun, isn't it? It's like the best day ever. I just get to say angle side side all the time. Now you know why I said you can't assume you make an angle side side out of you and me. You can't assume anything because you make an angle side side out of you and me. I've said it once or twice probably. You probably were texting somebody. I'm just harassing you, okay? I wasn't here yesterday. I'm sorry.
Who would miss the harassing?
Jeez, why are you so mean to me? All right. So this is the time that it does occur from time to time. It'll show up. It's not very common. What happens is that you're going to be able to show that triangles are congruent in a bunch of different ways. Sometimes you'll have more than one way that'll show up, but it always depends on what information that you're given. Now, what I want to show you guys is a couple of examples as far as wow. Wow. Still have a couple of months.
No.
Wow. There goes Maggie's grade.
I know it's but you made it.
So hopefully you're not on a borderline. Nothing. You missed it. We literally didn't.
You can't always get it done.
It was a wager that I made for the first hour if they win the World Series. Thank you for that trip. Really much nicer person. Fine. All right. So what I'm passing around for you guys.
He said.
in your class. Are you going to give out a study guide for the final?
What's that?
Are you going to give out a study guide
Generally do, yeah.
for the final?
Bro.
So what happens here,
Hit my head.
what I want to show you guys here is that these are just a bunch of quick examples. And I want you guys to get in the habit of being able to look at a diagram and be able to mark extra information that you might need. For example, I want you to look at number 1, and I also want you to have your progression sheet out, because I want to add a small bit of information about number 1. Okay? Now, it's not, we're not going to go on a full progression about how to do this yet, because we're not doing proofs today. I just want you to have this bit of information, because this is something that shows up over and over and over again. Okay? Yeah. What I want you guys come on. What I want you guys to see, is that part right there of the triangle is shared between both triangles, the 2 triangles on the sides. Do you agree? That is what we call a shared side. That's what we call a reflexive side. So what we do here is I want you to put in here a little reminder. Look for a reflexive side. Now, reflexive side is a shared side. Don't fill the rest of that, because I'm going to show you guys how it's going to work with a proof probably Thursday. We still have another day of building into these things before I even put down a piece of paper or 2-column proof yet. All right? Yes, ma'am. Don't do it yet. I'm going to tell you. I'll show you why when we fill in the rest of it about what it's going to look like. It's not a bad idea to have a small. If you want to put the small picture of what a shared side looks like, go for it. I have no problem with that. Don't label anything yet or anything, because I don't want to write down what you're going to do with it, because basically what I want you to see is that when you have a shared side, isn't it congruent to itself? Isn't this segment congruent to itself? So I can do this. Put a tick mark on it. Now what do you have for those 2 triangles? If you look at the tick marks, what does it have? Side, angle, side. There is no side-side angle, because you want to make sure, if you look, you have 2 sides and the angle between it. So come on guys, these 2 triangles can be shown to be congruent to each other because of side, angle, side. On number 2, is there an overlap? Is there a shared reflexive side? Yeah, that diagonal. That diagonal is what we would call reflexive. It's congruent to itself, therefore the 2 triangles become congruent because of side, side, side. The only ways that you're ever going to be able to show that triangles are congruent are with the alphabet soup. These 5. Are there others? Yes. Am I going to bother with them? No. There's leg, leg altitude. Okay. What about number 3? What do they have there?
Angle, side.
Very good. Angle, angle, side.
Why do you have the order?
Well, is there such a thing as side, angle, angle?
No, but no.
You have 2 angles and then a side opposite. You have 2 angles and then a side opposite. It's angle, angle, side.
Why is the side angle or angle?
It's the side between the 2 angles. That's why.
Okay.
You're basically picking a spot. If I start on the outside here, I have an angle, a 2 tick mark angle, a 1 tick mark angle, and a single tick mark side. 2, 1, 1. Same thing, angle, angle, side. That's how that works. So do the next 6, take a couple minutes, mark the diagram, do the next 6, and we'll check them. Mark up, you'll see here, just about all of them have that reflexive side. That's going to be a step that we're going to use in proof here very, very regularly. And we'll talk about how to write that out here in a minute. Do those next 6, and we'll check them in a second. All right. So, real quick, guys. Remember, anytime you see a diagonal across between 2 like that, where the triangles are sharing something, please call that the reflexive side and mark the diagram with tick marks. So that way you know right off the bat that these two, or that segment is congruent. So then you have an angle, side, and an angle. You do the same thing on the next one. Look at that. What does that become?
Side angle side.
Don't you sass me. Side, angle, side. Now on 6, right away you know that you have a right triangle. In that right triangle, you happen to know that your hypotenuse are the same, and you also have legs that are the same. So can you say hypotenuse leg in this case?
Yeah.
Yes. What's another option? You can do side, 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 because isn't that shared?
Yeah.
That was one option. And then if that's also shared, don't you have side, angle, side as well? Because you have the angle here. So what's going to happen here as we get into the actual two-column proof stuff, depending upon the information that you are given, it's going to be up to you to decide which method are you going to use. Some methods are going to be faster than others. It's just a matter of what you know. And the idea of being able to mark diagrams is key. You can't mark diagrams, so you can have a marked one. Okay? Now, number 7 and then also number 11 is one of the types of shapes of a diagram you're going to see quite often. Whenever you see those that kind of resemble a bow tie, where the tips of the two triangles meet, those create vertical angles. What do you know about all vertical angles? They're congruent. That's one of the things that are on your progression sheets. I put a little thing that said, look for congruent or vertical angles. That's something that you're allowed to mark in a diagram. That's thanks for being a good sport.
Next time, could you not do that?
Sure. You're welcome. That's one of the things you're allowed to mark in diagrams. It's something that you can state in your proofs. So there's more than one way for this one as well. You had a right angle, you had a right angle, you had hypotenuse, hypotenuse, and a leg. Here you had a hypotenuse leg. If you notice you had vertical angles, you could have said side, angle, side. That would have worked as well. You had vertical angles. You had angle, side, angle here also. Depending upon the information that they give you, you're going to be able to come up with more than one way to solve these. Yes, ma'am?
So if we only come up with one, are we going to get marked off?
No, and it depends on the problem. Well, all I want you guys to do here today is which ways could you show it?
Okay.
Okay? When we get down to the actual nuts and bolts of writing out a proof, you're going to see real quick that it's going to send you in one direction versus another.
Okay.
Sometimes you're not going to have enough information to do that side angle side version. You might have to do something else. Okay? But it's key to be able to mark your diagram back and forth. What are you doing number 8?
Angle, side, angle.
Very good. You've got your reflexive side here, angle, side, angle. And then lastly on 9, what do you got?
Side, side, side.
Side, side, side. Okay? Terrible?
No.
Good. I have 15 of these for you to do just like this.
That's a check mark.
This is down. Everything else becomes so much easier. So much easier. Now, before we run out of time, and I know these things are getting passed up slowly. Oh, I'm sorry. Excuse me. While these things are getting passed up to you guys, I'd like you to go ahead and look over at number 11. We have not done one yet. Thank you, sir. We haven't done one yet that has parallel lines. And if you look at your progression sheet, if you are ever given parallel lines, it always said to look for angle pair relationships. Okay? So when I'm looking at number 11, you'll notice that you have two different sets of parallel lines. Both of those lines go through the segment AS, which is playing the role of a transversal here. So what I'm going to do is kind of overdraw these two lines. And then I know I have this transversal here. If I do that, I know that I wind up with sets of angles that'll be congruent. Now, in this case, you get corresponding angles here and here. And then if you go to the other set of lines, you get another set of corresponding angles.
Oh, is he?
If I go this way, I don't know if it shows up very well. If I go the other direction with BC and ST, notice how you get another set of corresponding angles here
Oh, wow.
and here. Guys, take a look at what that diagram looks like. Doesn't it look like two flags on top of one another? Very similar. Let me give you a little bit of a hint. Anytime you see that set up like that with parallels, 9 times out of 10, if it looks like that diagram, it's going to be corresponding angles. You're going to be getting corresponding angles. Okay? And what do you wind up with here in the diagram? Angle, side, angle. Now, on this sheet, there are some of them that you cannot do. So it is a possibility that you can come up with an answer that's not possible. But mark your diagrams, go through it. There's 15 of them. It should not take you very long. But be careful with it. Look for your patterns, okay? Deal?
Yeah.
Yes, ma'am. No, because you asked me not to, so I'm not going to. Give me 1 second to just pause this real fast.
Is it okay if I just put my stuff here?
Yeah, it's fine. It's fine. I won't. I'll try not to hide it.